Okay, x is approaching 0, not infinity. So ignore the blue part of the limit flashcard. Just move right on. It says to factor and divide. Raise your hand, please. When you look at this numerator, is it best to think of the numerator as being made up of factors, or is it best to think of the numerator as being made up of terms? If you forget, Amanda Lindstrom was kind enough to make a sign. That's a little hard to read because of the glare sometimes, but she wrote, factors are a thing times a thing times a thing. And then she wrote, but a term is a thing plus a thing plus a thing. So when you look at when we look at the purple, you could argue that it's terms, you could argue that it's factors, but there's a best way to look at it. So hands up, what's your opinion? What's the best way to think of that purple expression? Terms or factors? Everybody who helps out this time? Let's go Jason.
Factors.
How many? 2? How many agree? Point, 2 for Jason. So I look up there and I see 2 factors. So I'm supposed to factor and divide, but that thing really is already factored. I don't see any way to factor it more, so I just move on. Now I look at the bottom. Questions first of all. Anybody bothered by any of that? Cool. So now I look at the denominator. The denominator also has 2 factors. This can be factored further. But the only reason for factoring typically is so we can divide something in the top with something in the bottom. So factoring this more isn't going to help because 4 minus x squared can be rewritten as 2 subtract x multiplied by 2 plus x. But I don't have a 2 minus x factor or a 2 plus x factor in the top, so there's no need to factor. So you want me to talk about that idea again. Like that's what's going through my head when I'm reading this little note here to factor and divide. Is no sense factoring if it's not going to help me divide. So, questions? Solid. So now all we're left to do is to find the left and right limits because there is nothing to divide. So back to Hunter, 2 more for him. In this case, we do need to do the left-right limit thing because we're approaching 0, not infinity. However, to save some writing, see, on the last homework packet, they said to analyze the continuity. On the AP test, they're going to want you to show them that you understand that to determine continuity, you have to specifically think of function value, left-hand limit, right-hand limit, etc., like you did. Here they're just saying find the limit. So you are free to do less writing. You can simply think to yourself, okay, if x is close to 0, just take it one little piece at a time. If x is close to 0, can I erase the board? Okay. If x is close to 0, just say it out loud. It doesn't matter whether the x is a little more than 0 or a little less. Please say out loud, what will the orange become when x is close to 0? Say it. 1. Everybody clear? Just keep going. Say it out loud. What's the green going to become when x is almost 0?
6. 7.
Some people said 7, some people said 6. So look at it again. When x is getting really, 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 really close to 0, what will the green be? Say it.
6.
Better. Good. So use your hands now. So this is 0, and you just count. So show me on your hands, what will this top formula become when the x coordinate is either a little more than 0 or a little less? Show me on your hands. What will the result of the numerator be when x is almost 0? So 2 points for voting. I got people doing this. So top two are multiplying or adding? Multiplying. So the first one's 1. The other one is 6 times 1 is 6. The top's getting close to 6. Raise your hand, please, if you know what the bottom is getting close to. Hands up. Raise your hand if you can tell me what will the bottom get close to when the x-coordinate is almost 0, either a little more or a little less than 0. What's the yellow going to compute out to be? Everybody. You can do it. Come on. Just raise your hand this time. Sorry, it's very confusing. Sorry, Lexi, I go back and forth. No. So what did you get?
7.
So you added again. You took you said.
Oh, I'm supposed to multiply. 12.
Do you see why you multiplied?
Yeah.
No worries.
My bad.
2 for Lexi. How many got 12? 1. Okay. As I try to always say, I don't care if your answer is right or wrong. You just got to talk it out. So, okay. Anybody else? Sweet. So the value limit is 1/2. That means if you were drawing a graph to depict this situation, what you would say is, when the x-coordinate is almost 0, the y-coordinate is 1/2. So say this is 1. That means we have a y-coordinate like here. And we have a y-coordinate here. We do not know what we have not calculated what the y-coordinate is exactly at 0. That was not part of the question, because we're finding a limit. We're just finding out what's happening when x is almost 0. You want me to talk more about that? Oh, please.
I just have a question. Is that all the work you can show, or do we have to show more work than that?
2 points, Jessica. For this one, no, that's sufficient.
Okay.
Yeah, it literally is a problem, Jessica, that can be done completely in your head.
Okay.
Yep. And actually, on the written section of the AP test, if you stop here, 2 more for Jessica, it's a good question, you get full credit. There's no requirement on the AP test to simplify anything. So if you stop at the purple, they give you full. Please, Jason.
You have to square your answer like that?
No, you don't. Unless it's unclear what your answer is. Is that fair? Like if you got kind of a lot of stuff and it's a little unclear where the answer is, I would make sure you let them know where it is. So, 2 more. Cool. We need to do the second part, which is finding the horizontal asymptote. So we need to find the limit as x approaches infinity. I think we should write it down again. So write this on your paper. Limit as x is approaching infinity. We can do a little bit of work in our head now to save some time. According to the limit flashcard, when we are finding a limit as x approaches infinity, we're supposed to compare terms that are adding. Please raise your hand if you can tell me some terms that are adding in this formula. We need to compare things that add. So hands up, who can tell me things that are adding? Hands up. If your hand is raised, give yourself a point. We're going to call on Tessa. Name 2 things that are adding, Tessa.
7x plus 6 and 5x plus 3.
Nicely done. So just taking those one little bit at a time, we've got 7x being added to the 6. So if those 2, Tessa, when those 2 add, as x gets bigger and bigger and bigger, because x is going to infinity, which one, the 7x or the 6 will dominate, Tessa?
7x.
Does that make sense to you?
Yeah.
3 points for Tessa. Stella, same idea. She said the other terms that we're adding, she mentioned 5x and 3. Which is dominant of those 2 terms?
5x.
Make sense? 3 more for Stella. Questions? Somebody else volunteer to tell us what else we would be thinking. Please.
1 plus negative x and 4 plus negative x squared.
So Carrie Ann said we've got the 1 and the negative x. 2 points for Carrie Ann. Somebody else, what's the dominant term between the 1 and the negative x? Let's go, let's see. Jackson,
Yeah.
Brinton.
Yeah. The negative x.
I'll give you 4 points for that. People often forget the negative. It's 1 plus negative x. So that's the dominant term. And then what else? Somebody else? Let's go. Let's say it. Anna Conley.
Yeah, the negative x.
4 points as well. Nicely done. I need someone else to volunteer to help me. I'll pay you points. Just need a hand. There we go, Dylan. So what I'm looking at now is this right here, Dylan, in parentheses. As x approaches infinity, I can think of that as really just being negative x. But this whatever's in the orange is still multiplying by whatever is in the purple. So I have to make sure I keep them as multiplying. So down here, my new limit problem is going to be negative x multiplied by 7x. And then what would the bottom look like, Dylan?
Negative x squared, 5x.
3 points for Dylan. Questions? Please.
What makes something the dominant term in it?
Gotcha. So today we're only talking about power functions and just power functions. So what causes the dominance is whichever of the two terms has the greatest power. So this is 6x to the 0 power. This is 7x to the first power. Did that help? 2 more. Please.
So when you're saying like as x approaches infinity, even though at the top it's x approaches 0, is that only applied to the first part of what we did? Okay.
Perfect. Yeah, so like if you look at the very start of the handout, it says, for every problem, find the limit as specified. So we did that. Then it says, also identify if the function has a horizontal asymptote. So we're working on that second part. And our flashcard said, 2 for Riley, to find out if the graph has a horizontal asymptote, we want to find the limit as x approaches infinity. Good work. Please, Jessica.
How do you know if it's x approaching negative infinity or x approaching infinity?
2 points. Everybody listen close. You have to check for both. So we're starting with this, but the good news is that when we're doing 2 for Jessica, when we're doing power functions, this little step here where we compare terms that add, for power functions, the comparison is identical whether you're going to positive or negative infinity. So we're saying positive infinity, but the work would be identical if it were negative infinity for power functions. Next time we're going to deal with exponentials. They don't behave the same, so don't use the same rule. Pretty good. Good question. Awesome. Okay, next step says we're supposed to factor and divide. So, hands up please. Looking at this numerator, is it best to see the numerator as factors or terms? Hands up. Is it best to see the numerator as factors or terms, Brooklyn? How many agree? Point 2 for Brooklyn. That means I can list out the factors completely separate from each other because they're all just multiplying. So I could do this. This is the limit as x approaches infinity. Or really, like I said to Jessica, it could be negative infinity. It doesn't really matter. And I get, let's see, I'm going to get negative x, which is really negative 1, multiplied by x, multiplied by 7, multiplied by an x again. I can literally list the factors one by one. Then I can just pair them up as is convenient. So I'm going to put a negative 1 on the bottom. I'm going to put one of these x's here. I'm going to put the other x here. I'm going to put a 1 there, and I'm left with a 5 on the bottom. And I'm also left with an extra x on the bottom. Like that. Questions? Please.
Okay, so just to clarify, when you do that, You compare everything underneath, but everything that didn't fit, you just put a 1 on top of it as a numerator, and you just put the other term on the bottom.
I did. This is not a method you need to memorize.
Okay.
This is something that should be understandable to you so that you can use it effectively. You can do the blue step in your head. You don't have to write it out. I just found that if I don't write it out, usually about half the class is like, whoa, how did you get there? So I just put everything separate. And the reason I did that is now I can see something divided by itself is 1, so that's 1. Here's another 1. Here's another 1. The 7 and 5 are numbers. The most interesting thing is this last piece here. Raise your hand, please, if you can tell me. As x gets very, very positive or very, very negative, what will happen to the purple box? Hands up. As x gets very, very positive or x gets very, very negative, what happens to the purple box? Like, what value will the purple box have? Because that's all we're talking about is x is going to grow forever. We're looking for a horizontal asymptote, so we're really thinking of x approaching positive or negative infinity. As x grows forever, what value will the purple box have? So that's going to be like 1 over 1 trillion, or 1 over negative 1 trillion. Ian?
Would be close to 0.
The purple box will be very close to 0. Show me your hands if you knew it. 0.2 for you. Do you want me to talk more about it? It's 1 over really, really big is really, 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 really small. So now you know. You've got 1, that's the green, multiplied by another 1. This is basically right here. This is 7/5. You put those two together. But they all get multiplied by really, really close to 0. Therefore, as x approaches infinity, this whole thing is going to approach 0. Questions? As x approaches negative infinity, the result is exactly the same. Because to get from here to here, when we're comparing power functions, remember, power functions compare the same whether they're positive infinity or negative infinity. So we get to this statement here either way. If x is negative infinity, this is still going to equal 1. This is still going to equal 1. The whole thing's going to approach 0. So you can write down the answer now, which is, as x approaches infinity, y approaches 0. As x approaches negative infinity, y also approaches 0. So we have a horizontal asymptote at y equals 0. Questions? Please, Jackson.
So is the, like, do you know there's a horizontal asymptote when they both are the same? Or like, how do you?
Oh, awesome question. I'm going to give you 4 for that one. No. We will encounter examples. I don't think there are any in this homework. But when we go to the next homework where we have ln and exponentials, we'll have cases where as x approaches infinity, y will approach one number. But then as x approaches negative infinity, y will approach a different number. That means you actually have 2 horizontal asymptotes. So you could think of this as being 2 horizontal asymptotes, 1 in each direction, but they're just the same one. Did that answer your question?
Yeah.
Okay. Anyone else? Solid. Let's go do together